When a beam made of an elastic material is bent, both the stress and strain increase with distance y from the neutral axis. At a certain point, the material cannot carry any more stress. The material reaches what is called its yield stress, denoted as sigma yp. If the beam is bent more, permanent deformation occurs. As the beam is bent, some of the extreme fibers yield. That is, they reach and carry their yield stress. Those fibers that are in tension at their yield stress will be permanently stretched, while those in compression will be permanently shortened. Those fibers that have not reached yield stress are still elastic and are governed by Hooke's law. In summary, stress is linear with respect to y in its elastic range, but in the plastic range does not exceed the yield stress. Strain, on the other hand, remains linear with respect to y throughout the depth of the beam. Another way of looking at the relationship between stress and strain in the elastic plastic case is to use the stress-strain curve to determine the stress at each point. If the radius of curvature is known, then the strain can be found at any point using the equation epsilon equals minus y over rho. The fiber shown in green is in its elastic range. The stress at this strain value can be read off the stress-strain graph. For another point further from the neutral axis, the strain is above the yield strain, epsilon yp, and the stress is sigma yp. By repeating this process, the stress at all points across the depth of the beam can be found.